Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we're going to go through on double integral. Okay, so basically in this syllabus we are focusing on a function with more than one independent variable. So for double integral, so we're going to integrate to both x and y. Okay, so let's take a look at the first part for rectangular region. Okay, when we have all limit as a constant. So since it's a function with two independent variables, so it can be dx dy or dy dx. Okay, by Frobenius theorem, we can just interchange the order. Okay, so let's say if in these cases we have dx dy means that this limits represent for y and this limit represent for x. We can also interchange the order by taking dy dx. So in these cases we just interchange the limit also. Okay, so how can we integrate? Okay, so in the first case, if we have dy dx, so we must first integrate in the bracket first. So in these cases, we have to integrate respect to y by making x as a constant, and later we integrate respect to x. For the second cases, we're going to integrate respect to x first by making y as a constant, and then later integrate by respect to y. Okay, so let's take a look at the simple example. So let's say we have xy. So let's take a look. If we have dy dx here, so 0, 1, 0, 2, let's say. Okay, so in these cases, we're gonna integrate respect to y first. So we have xy squared divided by 2. So the limit for y is 0 up to 2 here. Don't forget to write the limit for x, since this one is not completed yet. Okay, so from here we substitute the values of y. So we're gonna have x to the power of 2 divided by 2 minus with 0. Okay, don't forget that this one is still not completed, so make sure that you write the integral for x. Okay, so we're gonna have 2x, right? So now we integrate respect to x. Okay, so we're gonna have x squared divided by 2. So substitute the limit 0 up to 1. Okay, so we're gonna have 1 over 2 minus with 0. So the answer will be 1 over 2. Okay, so same goes to if we change to, so let's say we change into xy, so dx dy. So if you change into this order, means that the limit here will be 0 up to 1. So here is 0 up to 2. Okay, so you can take a look at this example. So in these cases, we're going to integrate respect to y first and followed by x. Okay, in the second example, you can see that by Frobenius theorem, if you interchange the order, you will get the same answer. Okay, so you can try to answer this question by your own and then compare the answer. Okay, so in this question, they give you straight away the limit for both x and y. But what if we just give like this? Okay, it's just a situation, a rectangle with vertices. Okay, so in these cases, you have to sketch first. Okay, so from the condition given, so we can have this kind of sketches. The region is in the shaded region. Okay, it's a rectangular region. So you can choose either you want to use dy dx or dx dy. It will give you the same answer. Okay, so same goes to this example too. So make sure if the question didn't give you the limit, okay, they will give you the situation, so make sure you sketch first and later on you decided the limit and the type, whether you want to use dy dx or dx dy. And please bear in mind that by Frobenius theorem, for the constant limit, you can just interchange the order. It depends on your choice.